Now let's find a unit vector perpendicular to the plane. It says that we have to find a unit vector that is perpendicular, and once you see this, you already know that we'll use the cross product, and the plane contains a and b, vectors a and b, and we'll also have to find the sine of the angle between them, right? So some of you may have already guessed how you will find the sine, and everything is so related to each other, honestly. But let's see how we'll do this. So a is this vector here and b is this vector here, and the plane that contains a and b, we need to find a unit vector perpendicular to that plane, right? So let's see. A vector perpendicular to a and b is obviously a cross b. As you know, a cross product always gives you a vector that is perpendicular to the two vectors that the cross product is being taken of, right? Because if you remember that vector n is perpendicular to the two vectors. So let's take the cross product, and as you already remember how to take the cross product, and again let me just remind you how to do that. The first term, I into 6 plus 9, how do you get it? You look at this I over here, you cancel out its column, you cancel out its row, and then you write down plus I, and then you multiply that with the product of these two vectors minus the product of these two vectors, and that gives you 6 plus 9. And the second one is minus j. So as you remember, now what you'll do is you'll do the same thing for j, but remember j is negative, not positive. I and k are positive, j is negative. Now again, cancel out the row of j, the column of j and the row of j, and then multiply 2 and negative 1, subtract that, and then from that subtract the product of minus 3 and 4. Always work in diagonals, and that gives you minus 2 plus 12, right? And same for k again, but k is positive, right? So plus k, and into 6 plus 24. Again, how do you do that? Cancel out the column, cancel out the row, multiply 2 and 3 minus negative 6 into 4. That gives you 6 plus 24. Now that you've done that, you get this. So this is the cross product of a and b, right? Now you need to find the unit vector of this vector, right? So to find that, you first need to find the magnitude of a cross b. Well, you do that simply by taking the squares of all the terms and adding them up, and then taking the under root of the resultant value, and that gives you 35 in this case, right? So now what you need to do, the unit vector perpendicular to the plane containing a and b is a cross b over the magnitude of a cross b, right? And that gives you this. Now we need to find the sine of the angle. So first you need to find the magnitude of a, and the magnitude of the vector is, again, you need to take the squares of all the values of I, j and k, take the under root, and that gives you 7. You need to do the same for b, right? And that gives you under root 26. So let theta be the angle between a and b, right? And we need to find the sine of the angle. So sine theta is equal to a cross b, the magnitude of a cross b, into ab sine theta. And you remember this by the formula, which was that a cross b is equal to the magnitude of a into the magnitude of b. Oops, sorry. The magnitude of b. My mistake. The magnitude of a into the magnitude of b into sine theta, right? In case of the dot product, it was cos theta, but in this case it's sine theta. And we already found out the magnitude of a cross b, and we found out the magnitude of a, and like this, we found out the magnitude of b. Just divide them, and this is what you get. So the sine theta is equal to 5 over under root 26.